Hey everybody, first of all, gosh, sure miss y'all. So sorry about what's going on, but we're going to make it through. Alright, so today we're going to be talking about position, velocity, and acceleration. And I have shared a document with you called Position, Velocity, Acceleration Notes for AP Calculus. So I'm not going to write all those notes down. I would encourage you to write them in your notebook. If you have a printer, you certainly can print them out. But we're going to be doing the examples that are found on that shared document. So first of all, it kind of defines the position function. Is the original function you're given usually. Velocity function is the first derivative of the position function. So if you're looking for a velocity, then you're going to take the derivative of the position, and then if you're looking for the velocity at a specific time, you'll plug in that specific value for t. And then acceleration is the derivative of the velocity. So acceleration is the second derivative of the position function. And all that's listed on that little shared document. Speed is going to be the absolute value of your velocity. So the velocity is the derivative of the position, and then speed is the absolute value of velocity. And that's because velocity is going to be either positive or negative, but your speed is always positive. So it's going to be the absolute value of the velocity. When the velocity is negative, then that means the object that they're talking about, and often in the AP exams it's a particle. That means it's moving to the left usually, sometimes it's moving down. When the velocity is positive, then the particle's moving to the right, or sometimes that's listed as up. When the velocity and the acceleration have the same sign, either they're both positive or both negative, that means that your speed is increasing. When the velocity and the acceleration have opposite signs, then that means your speed is decreasing. When the velocity is 0 but the acceleration is not, then that means your particle has stopped and is changing direction. So when they ask you when is this particle changing direction, you're simply going to set the velocity equal to 0. Again, all of these notes are on that shared document. All right, so we're going to look at some examples. That was a lot of information, but we can do this. All right, so number 1 on that shared document says if the position of a particle at time t is given by the equation x of t, and students hate that they use x as the name of a function, but that's often what they'll use, and also s's in Sam. So x of t, or sometimes on the AP exam, s of t. So x of t, our position function, is t to the third minus 11t squared plus 24t. Okay. It says to find the velocity function. So we're trying to find v of t and find the acceleration at time t equals 5. So we're trying to find v of 5. So after 5 seconds, find its velocity and find its acceleration. Okay, we're given x of t. All right, so the velocity is simply the first derivative of our position function. So that's going to be x prime of t. So our derivative is going to be 3t to the second minus 22t plus 24. So there's our velocity. And then acceleration is just the derivative of the velocity, second derivative of our position function. So that's going to be 6t minus 22. So now our velocity at 5 seconds, v of 5, I'm going to come down here, is going to be 3 times 5 squared. I'm going to go ahead and do that. Minus 22 times 5 plus 24. So that ends up being, I'm going to abracadabra that. Let's see, because I don't feel like doing that math. Velocity at 5, and we get negative 11. Negative 11. So since our velocity is negative, that means we're moving to the left. And then our acceleration at t equals 5 is just 6 times 5 minus 22. So that's going to be 30 minus 22 is 8. All right. So even though they didn't ask it, notice that our velocity is negative, our acceleration is positive. So that means, remember that means when the velocity and acceleration have opposite signs, the speed is decreasing. They love to ask that question. So what they will do on the AP exam is they'll give you the position function, and then we'll say at t equals 5, is this particle's speed increasing or decreasing? So you will then have to know, all right, to see if the speed is increasing or decreasing, I need to find the velocity and the acceleration at that given t and compare the signs. Even if they were both negative, that would mean that the speed is increasing. It's whenever the two signs are the exact same, the speed is increasing. But when they are opposite, that means speed is decreasing. So that was a nice little basic one to get our feet wet here. And no, Jack, they are not going to stay that easy. They never do. All right, example 2. Let's see, if the position function of a particle is given by x of t equals t to the third minus 12t to the second plus 36t plus 18. And they say where t is greater than 0. Usually they're talking about time, a positive time frame. You usually don't go back in time. All right, part A, we want to find the point at which the particle changes direction. Well, if you go back and look at your notes, the particle changes direction whenever the velocity is 0. All right, well, that's not going to work. Okay, so let's see, blah, blah, blah. Yeah. All right, so our velocity is the derivative of our position function. So that's going to be 3t squared minus 24t plus 36. So this particular particle changes direction whenever the velocity equals 0. So we're going to take that expression, set it equal to 0, and now we're just doing algebra 1. And the easiest thing to do here is factor out anything common, which in this case is a 3. And in fact, not only can you factor it out, but since it's just a constant, you can actually divide everything by that, and so just kind of ignore it from then on out. So now I'm going to factor this. That factors to be t minus 6 times t minus 2. So there are two places where this particle changes direction, at time equals 6 and at time equals 2. All right, the point at which the particle changes direction is 2 places. Okay. And then part B says find the interval of time in which the particle is slowing down. All right, it's slowing down when the velocity and the acceleration have different times. So I need to find my acceleration, which is the derivative of my velocity. So that's going to be 6t minus 24. So now we've got to kind of combine some things that we've done before. We want to know when the sign of the velocity and the sign of the acceleration are different. So let's see, my acceleration equals 0 at t equals 4. So what I found here is a critical number. So I've got critical numbers for my velocity, critical numbers for my acceleration. So what I'm actually going to do is I'm going to make a chart using all 3 of these critical numbers. So I need my chart to go, and my time starts at 0. I'm going to fit my chart right here. So we're going from 0 to my lowest number, which is 2, and then 2 to 4, and then 4 to 6, and then 6 to forever and ever and ever and ever. So I'm going to look at my, well, I need my, what are they called? The number I'm going to plug in. I can't think. But we'll use t, and then we want v of t, and then we want a of t. All right, so a t, a number that's between 0 and 2 might be 1. So first I'm going to find v of 1. So here's my v of t, all nice and factored out because that's where I like to plug it in. So 1 minus 6 is going to be negative. 1 minus 2 is going to be negative, so when I multiply those, I get a positive. And I'm just going to do the whole chart for my V first. A number from 2 to 4 is 3, so if I plug a 3 in here, I get 3 minus 6 is negative, 3 minus 2 is positive, so when I multiply those, I get negative. 4 to 6, I might try 5. So 5 minus 6 is negative, 5 minus 2 is positive, so that's going to be negative again. 6 to infinity, I can use any number, I'll just use 7. 7 minus 6 and 7 minus 2 are both positive. Now let's look at acceleration with these same numbers. So when I plug in 1 into my acceleration, so here's where I'm plugging it in, 6 minus 24 is going to be negative. When I plug 3 in, 18 minus 24 is negative. When I plug in 5, 30 minus 24 is positive. And when I plug in 7, 42 minus 24 is positive. So the question asks the interval of time in which the particle is slowing down. It's slowing down when the velocity and acceleration have different signs. So we're looking at right here, because one's positive and one's negative. And then right here, because one is positive and one is negative. The other two time frames, we're speeding up because the signs are the same. So on the AP exam, remember you can't just leave your information in a chart, you have to sum up. So let's see, the interval in which the particle is slowing down, the particle is slowing down on the interval from 0 to 2, and the interval from 4 to 6. And the AP exam this year is all all free response. So you want to make sure you sum up what information you found. I wish I could tell you that there would for sure be a position, velocity, acceleration. I think there may be. On the real AP exam, there's always a few questions about this, but I'm not sure yet about this new AP exam they're going to give. Hopefully they'll give us a little more information. All right, so that was example 2 from that shared document. Not one on the room. Get rid of that. All right, example 3 says given a particle's position as x of t equals t squared minus 6t. Nice simple little equation there. Part A, how far does it travel between the 8th and 10th seconds? How far does it travel? Well, how far it travels, what we're going to do here is actually figure out its position after 8 seconds and its position after 10 seconds. And then we can figure out how far it's traveled. So we're actually not going to do a derivative yet for this, but to figure out where it is at 8 seconds, we just want its position at 8 seconds. So we're going to plug 8 in for t here. We're going to get 64 minus 48, which is 16. So at 8 seconds, if we were thinking of a number line, our particle is sitting over at 16 on the number line. At, where else are we looking? 10 seconds. So x of 10 is 10 squared, which is 100, minus 6 times 10 is 60. So now it's sitting at 40. So possibly, and there's a reason why I'm saying possibly, it asks how far does it travel? Well, it's gone from 16 to 40. So to figure out how far it's traveled, you just take 40 minus 16 for our distance. And it looks like it's traveled 24 units. Now there's actually something we have to see first. Before we know that it's actually traveled that far, this particle could have, at 8 seconds, be at the 16, but then it might reverse its direction until it hits 9 seconds and then go again to 10 seconds and end up at 40. In that case, we'd have to add the distance that it reversed and then add that distance that it went to the right again. So what you need to do with these are kind of trick questions, and I can almost guarantee that this is going to happen. You want to make sure it doesn't change directions within your time frame. Remember, it changes direction when the velocity is 0. Changes direction when v of t equals 0. That's in your notes. So what I want to do with this is I want to make sure that this particular particle isn't changing directions between 8 seconds and 10 seconds. So if this is my position function, then my velocity is just the derivative of that, which is 2t minus 6. So when is this particle changing directions? Well, it changes directions when the velocity equals 0. So this changes directions at 3. So we're good with what we did. At 8 seconds, it was on 16, and at 10 seconds, it was on 40. So just subtract those, and that is that's how far it's traveled between the 8th and 10th seconds. But now notice part B. It says how far does it travel between the 2nd and 4th seconds. So since we know it changes direction at 3, we need to figure out how far it goes from t equals 2 to t equals 3, because t equals 3 is where it changes direction. Then figure out how far it goes from t equals 3 to t equals 4, because the example says how far does it go from 2 to 4 seconds. So whatever your interval is there, if there is a number within that interval where your particle changes direction, where the velocity equals 0, then you have to split that interval up at that point. So in this case, that was 3. So we split our interval, which went from 2 to 4. We split it up and did 2 to 3, and then 3 to 4. All right, so how far does it travel from t equals 2 to t equals 3? Again, you just need to know what position it is at each point in time. So the position at 2, going back up to our position function, is just 2 squared, which is 4, minus 6 times 2 is 12. So if you think of the number line as sitting here at -8 at x equals 2. At x equals 3, or excuse me, at t equals 3, then the position is 3 squared minus 6 times 3, so we're at -9. So how far has it traveled if it's gone from -8 to -9? I can't hear you. All right, so the distance it travels from -8 to -9, I'm going to come down here. You simply, first of all, distance is always positive. So distance is going to be, and it doesn't matter the direction in which you subtract because you're taking the absolute value. So distance is going to be, I'm just going to do -9 minus the -8. And so it has traveled 1 unit from t equals 2 to t equals 3. It's only traveled 1 unit. So again, find where it is at time equals 2, at time equals 3, and figure out how far it's traveled. Now, did you need to do this math to figure that out? I don't think you did. I think you could picture a number line and know, hey, it's gone 1 unit. You just don't use negative when you're talking about distance. All right, from t equals 3 to t equals 4. Well, we already know t equals 3. We already got the -9. When t equals 4, we want to find our position at 4, so that's going to be 16 minus 24 equals -8. Well, again, how far has it traveled if it goes from -9 to -8? It's only traveled 1 unit. So the total distance traveled, you add those two distances. It's just going to be 1 plus 1. So the total distance traveled is 2. So what we've learned here, the first part of number 3, the particle did not change direction, so we just figured out where it was at 8 seconds, or at time equals 8, not necessarily seconds, and at time equals 10, and then distance is, and let's just add this, the absolute value of that difference. But from 2 to 4, it changed direction at t equals 3, so we had to split that interval up and figure out how far it went from 2 to 3 and how far it went from 3 to 4, and then add those two distances up, and we got total distance of 2. So one more example like that, and it's going to be just like this one. If you want to skip this example, that's fine, or fast forward it or whatever. It's the last example, and then your homework is going to be another shared document, so you don't have to use your textbook. All right, example 4, our last one. says given the position function is x of t is t to the fourth minus 8t squared. We're going to find the distance the particle travels from t equals 0 to t equals 4. So first we need to figure out if it's going to change direction. It changes direction when the velocity equals 0. So my velocity is 4t to the third minus 16t. I'm going to set that equal to 0. I can factor out a 4t, and I'm left with t squared minus 4 equals 0. So I can factor that again to t plus 2 times t minus 2 equals 0. So I technically get 3 answers for t. 4t equals 0 gives me t equals 0. T plus 2 equals 0 gives me negative 2. T plus minus 2 equals 0 gives me t equals positive 2. But since I'm only looking from time equals 0 to time equals 4, all I care is that it changes direction at t equals 2. Changes direction at t equals 2, which is within this interval. So that means I need to split this interval up. I need to look at how far it goes from 0 to 2, and then how far it goes from 2 to 4. So from 0 to 2, plug in 0 for t. Let's see, t equals 0. Actually, I'll do it this way. X of 0 is just going to be 0. It's not always going to be 0, but in this case it is, because when I plug t equals 0, I get 0 there. X of 2 to the fourth is 16 minus 32, so I'm going to get negative 16. I'm going to check that real quick. 16, 4, 32. Yeah, negative 16. So how far has it traveled here? If it starts at 0 and goes to negative 16, remember distance is not ever negative, so the distance here is just 16. If you need to do math to get it, then you take the absolute value of 0 minus a negative 16, and you get a distance of 16. From 2 to 4, I already know that x of 2 is negative 16. X of 4, oh my goodness. What the heck is that? Let's see, 256 minus 16 times 8 is 128. So, is it 256? That seems excessive. 36, nah. Yeah, it's 256. So 256 minus 128, 8. Is that right? All right, I'm going to cheat and look. T to the fourth minus 8t squared, because I'm getting a big old number. Here we go. T to the 4. Well, they don't tell me what it is. 144. Okay, good. So, is that what I got? That is not what I got. They already added the 128. Okay, so that's negative 128. That makes sense. So x of 4 is 256 minus 128. So it's going to be a positive 128. There we go. So our distance is going to be the absolute value of negative 16 minus 128, which is the absolute value of negative 144, so it's 144. So my total distance is going to be the 144 plus the 16 equals 160. I hope that's right. Yay! It's so nice when the teacher knows what the heck they're doing. So 160. All right, so that's an example of every type of problem you're going to have to do. And again, your homework is just a shared document. All right, see y'all later. Bye.